Hi, this is Stefan Petersen. I'm going to give one other cmr42 tutorial, this time on the RV. So you've had an overview, you've seen how to import and review images and read images, you've seen how to do the LV analysis, you've seen how to do T2 star imaging, and now it's time to look at the RV. A lot of the things that I've said about the LV are true also for the RV, and I've explained a lot of the buttons already when I showed you how to analyze the LV. So hopefully this will be a little bit quicker than the LV tutorial, but it's still, but the RV is quite complex, in a quite complex shape, so we need to spend a little bit of time how to best choose your slices that you want to include. So you're familiar, I've basically, inpatient list, started a case. In this case it's a myocardial salvage case, which you can see is loaded into the viewer because you see this orange button. If I go into the series overview, I can then drag, this looks like this is the cine, I can drag this into the short 3D tool which allows us to analyze the LV and the RV, and as you can see it already dragged in the long axis views as well for the decision which ones to include and which ones not to include. But I guess this doesn't really work for the RV, so I guess we can ignore this. And you can see that if I take this toggle off, which is the second plane of the mitral valve plane, then you only see one. But yeah, so again you can toggle here between your anatomical images. You see got 9 slices, 12 slices here. And how many phases have we got? We've got 25 phases. So I always prefer to see this schematic. I guess you can always kind of change this slightly that you can see the entire schematic. I mean, I've explained the buttons, but just to remind you with regards to the RV, you've got all these tools. All these are LV tools: endocardial manual, epicardial manual, reference LV, RV junction. You probably won't need that for the RV, I don't think. Endocardial LV, basal slice, epicardial basal slice LV, papillary muscles, and this yellow one really is the endocardial RV contour and the epicardial RV contour. So those two are relevant if you want to do manually, and if you want to do contour detection endocardial, that doesn't work for epicardial. So if you're just interested in volumes, which I guess most of the time we are, then this one sometimes works quite well actually, so worth having a look at that. But important thing is, similar to the LV, we need to look at our basal slices and decide which ones to include. Now see, I still have some contours here, so I'll just delete those. If I click right mouse click, delete all contours of the series, they're all gone. So often for the RV is that where you chose your LV contour, so if we remember, and actually we did a different case, but in this case, just to look for LV, RV basal slice selection. So if, just going to zoom in a little bit and drag that over. We are in slice 1, phase 1. Would you include this for the LV? I wouldn't, because this all looks very much like atrial wall to me. If we are unsure, how do we do that? We look again. If I now click through into systole, we can see that this is getting larger, which means it has to be the atrium, because only the atrium gets larger in systole. A ventricle would get smaller in systole, unless you've got obviously dyskinesia. But normally the atrium gets bigger in systole and the ventricle gets smaller. So that's how we're uncertain, can make sure that this is the atrium. So this is the atrium. So we wouldn't include that for the LV. But often the RV has actually got at least parts that can be included for the RV analysis, because often the RV sits a little bit more basally than the LV. Again, would we include this? Is this ventricle or is this right atrium? It looks like it's right atrium, but again, if we're not sure, now just focus on this while I'm clicking through into systole. It's getting larger, so it has to be the right atrium. So we wouldn't include this slice. So that's the aorta and the outflow tract. That's the pulmonary artery, I think. You can see that here, that we're cutting through there, that's the pulmonary artery. And now anything that sits below the pulmonary artery is really right ventricle. So if you were absolutely pedantic, I think this little bit here, well, let's go to systole. This little bit here below the valve, this triangle here, because then we've got the aorta, should be included. So in a way, I would probably say endocardial contour, this is part of the RV. And RV shapes are different, so I may actually look at the end of the tutorial just to load a few other cines so that we can decide on what the best basal slice is. But here I would probably do this and not include this. If I now go one slice down, it becomes a little bit more tricky. Probably have the aorta here with the right coronary artery coming out. So that's the aorta. But maybe on top of that, we've got the outflow tract again. So what you also need to remember, if you choose and you're confident that this is part one further up is RVOT, which maybe I actually now revise this and I'm not. But then you can't possibly then say this is all aorta, because, I mean, once you've said that this is a basal slice, then this also needs to include some RV. Let's look at this here. Does this look like RV? I think it still looks very much like the right atrium, but again, why don't we just go into systole? I think it gets bigger pretty quickly. So it looks like it's the right atrium. And because this has the right coronary artery, I think I made a mistake. I think that this was actually still all aorta. So I will undo this and get rid of that. So our first basal slice might be this. Now this looks much more like a shape of the right ventricle, and I'm sure if I click into systole, it'll get smaller first and then get larger when the atrium then comes in, and that's what often happens. So you can see it gets smaller, so that was right ventricle, and now it gets larger, and that's now right atrium. So what we see here is that this all is basically part of the right ventricle. So I can draw a contour here. That's the RV in diastole. Then now all of this needs to be RV. And again, if you wish, you can actually change to Bezier, which might be easier for you. Where do you click, click, click. And now the other little thing that you should always do is, if you're uncertain whether you're including epicardial fat or whether this really looks like it's the RV, play it as a movie. And then check with the contours on whether you're happy with where you've drawn them. I am pretty happy here. Going to slice down. It's then all pretty clear. Once you're away from the right atrium, things get much easier. But then it becomes a little bit more difficult when you get lots of pericardial fat around the right ventricle, and then to say this is actually part of the cavity or is it actually pericardial fat, and that's when this helps you. In fact, I think maybe been a little bit too generous here and bring this in, but that's really how you do it. So here you can do shift key left mouse button can adjust. I'm sure there's quite a lot of fat in there, but if you're not sure where that ends, trick is play the movie. I think then that's probably alright. So all of this out here is probably pericardial fat. We go back one further down, and that's all, looks all like fat. I just play the movie to make sure. Yeah, it looks. And even if that was right ventricle, there would be such a negligible amount. It really wouldn't make any difference. And you can see here that we are in the pericardial fat. This is not the right ventricle anymore. One slice further up, you can see we are cutting into the RV a little bit still. So that's quite happy with those contours that I've drawn. Basal slice is always a bit more difficult. So here I would think we're actually in the right atrium. You can see the tricuspid valve there, and it is tight. We are probably near the outflow tract, so this is a bit confusing. So we'll look at some other cases. Here I'll make a decision that this is our first basal slice and this is more aorta. Okay, so then we go basically and check where our smallest cavity is, and I basically look at the left ventricle. It's much easier. So if we decide this is our smallest cavity, phase 8, I go to the base. So first of all, if this is our first slice, this is the first slice also, slice 3, where actually systole might contain some ventricle, and we've looked at this. I think this is the right atrium in systole, because again you've got some longitudinal shortening of the right ventricle, normally about 2 centimeters. That's what echo measures as the TAPSE. So basically it would be almost strange and would suggest a really poor RV function if you still have the RV in the same plane in systole. So this is almost certainly the right atrium, but to be absolutely sure, you may want to play the movie again. And I think you can appreciate there that in systole this actually is the right atrium. Now, would you include any of this? Again, probably worth just click following here. So maybe we could argue that this difficult. Probably wouldn't include any of this. I think this is more aortic valve and outflow tract. If we go one down, now you can see that it gets smaller in systole. So this must be the right ventricle, and this must be the outflow tract. So I would basically include all of this here. But this I think is quite a difficult case actually. Again, uncertain, just play the movie. I think I can be reasonably happy with that. Maybe I was exaggerating a tiny bit here. And I'll just, just bring this in a bit more. Further down. Wasn't good, but I can correct that in a second. There you go. Now I'm really not sure where it ends, so best to look at the movie. So maybe I've underestimated a little bit there, so I think it needs to probably come out a bit like this. Again here, contour, 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 contour. And that's it. So those are the endocardial contours. And if we get rid of these, remember you always get a warning when you don't use the same number of slices. If you don't like to see that, you're confident you haven't missed anything, forgotten, you can say disable the warning message. And you can see the end diastolic volume and the ejection fraction, 56%. If we typed in here the height and the weight, let's say weight was 80 kilograms and the height 175, say, then we would actually get in our report the cardiac index and the cardiac output should, why I'm not sure why the cardiac output doesn't show. It's 41.7 times 119 milliliters. But that's basically then calculates all the index values. And if you were so inclined and you had, you would be able to see the RV mass quite nicely, you could actually draw those contours, and I'll just demonstrate that to you, how you basically start, draw your epicardial contour. Double click, and basically it just ignores the rest there. And then you basically go down and do that for all of them. I'm not going to show you that now because I think that's really something that we clinically don't do. It's only if you had patients with pulmonary hypertension, you wanted the RV mass calculated, or you want to look for changes following treatment. Otherwise, I think the quick clinical trick is to just measure the wall thickness, and if it's increased, you may want to document RV mass, and that's how you do it. So the other thing is, when you're starting, always make sure when you've got a normal heart with no intracardiac shunt or no shunt and no significant valve regurgitation, then in theory your left ventricular stroke volume and your right ventricular stroke volume in the same patient should be almost the same. If they're not in somebody that hasn't got any pathology, then most of the time your contours are incorrect. So practice, practice, practice. Once you are confident that you get it right, the RV volumes and the LV volumes, and you see a difference, then you can argue, yes, there might be a shunt, or there might be significant regurgitation. You can use your stroke volumes that you've calculated for your calculations of determining, for example, the QP-QS ratio in shunts. But really, this is difficult. You need to practice RV contours quite frequently. And I think rather than showing you now how you draw the contours, I think you get the gist of it. I will just briefly show you how the endocardial segment, automatic RV endocardial segment detection works. You may or may not want to use that. And then after that, we'll just look at some basal short axes of different cases, and we decide which ones to include and which not to include. I think that's the really critical part. Whether you draw that contour slightly inwards doesn't make a big difference. Really is, on the whole, is this a basal slice? Is this right atrium or right ventricle? That's where the mistakes are usually made. Okay, so let's just delete all those contours. And now if we want to do the automatic contour detection, I've mentioned it for the LV earlier. If I do a double click, I get rid of that toggled epicardial RV contour. I can now move this so that the yellow circle which sits in the middle of this window sits actually in some brightness in the RV. Now, don't use the contour detection for the very basal slice. Do it manually there. But if you think that this is all part of the RV, now what it'll do is it'll look for the signal intensity here and looks around where you've got a contour similar to the RV shape, that basically where you've got a significant change in the signal intensity. So let's see. See, that's not bad. If you click on this a little while, it'll try to adjust. If you would like to say, actually, I want this included and I want this excluded, easy to do. You just go one slice down, make sure your circle is in the middle of bright signal, and you click on this. Yep, happy with that. One down, click on it. Maybe a bit too far out. If you're uncertain, don't forget to look at the movies and go back to your slice. So I'm happy with that. Go down one, and again, maybe a bit caught too much there, so you adjust it. Again, let's see what it picks up. Can grow it. Maybe you need to sort of adjust it here a little bit. Want to take this out. Get the gist of it. It does. I think the RV contour detection usually helps you. So now this wouldn't be so good. So as I've toggled the endocardial contour, I actually double click to get rid of this. Now I can move this so that the circle sits in some brightness, and I click this and I can grow this. Now this isn't perfect, so in that case I might just decide let's just get on with it and I'll manually help. But it did a good start. So that's really how you want to use the automatic contour detection, and you do the same then in your systolic phase. But what I do recommend is that particularly the basal slice, if you want to include a little bit here, just do it manually. If you were, for example, to say, I want to include this bit, and that's how you do it. Again, you might want to use Bezier lines, you might want to do the drag contouring. If I click this on, I drag the contour, you can see I can alter it. Or you say, actually get rid of this, I want to manually adjust, you can do it. So I think that's the RV in terms of manual contouring. You use this for endocardial contour. Very rarely you may need the epicardial contour. You choose your end diastole, end systole. In end systole you definitely only draw the endocardial contour, similar to the LV. And critical point is deciding where your basal slices are, both in end diastole and end systole. Then you click on the report to bring it to the report tool. Once you've got it all in your report tool, you click on XML report so that it becomes available for our report 42 analysis. If you want to put it into PACS, DICOM report or scientific report allows you to export it into CSV file, or you can print it, etc. if it's connected to a printer. Right, I think that's really what I wanted to say about the RV, but I did promise that we'd look at a few other short axis scenes just to discuss where to draw the basal slice. That's really critical. So let's go into some perfusion cases, because they should pretty much all have the cines, I would hope. So let's just click on this patient. Takes a little while to load the study, as you can see. cmr42 seems to be pretty reliable and not crash, but it does occasionally crash. Yeah, so we should watch out for this. If it happens too often, we just need to let the company know. Then maybe there's a setup problem, but I think generally it works extremely well. So as you see, it just took a little while to load. Let's identify our short axis cines. And is a short axis? No, actually, it's perfusion. That must be the short axis, just with the looks a little bit funny. So if I drag this into the short axis analysis tool, and with the shift button and the left mouse button I can adjust, or alternatively you can go to the one that usually works, right mouse click window min max, So if you, I mean really we are not drawing contours now, but just for LV and RV decision which ones to include in the basal slice. We are now in the first phase, so diastole. So we start at the top here. So this is clearly left atrium, clearly right atrium, very thin-walled aortic valve, aortic outflow tract, and that's the pulmonary valve probably. So clearly the first slice you wouldn't include. You go one further down, would you include this? This very much looks like the right atrium, very much looks like the aortic valve, very much looks like the pulmonary valve here, so this is above the pulmonary valve. You could argue if this is the pulmonary valve, then this is part of the right ventricular outflow tract. So in theory you could argue let's draw a contour here. And that's as much as I include, because this is the right atrium. If you're unsure about right atrium, go into systole and you can see that this is changing its shape and it looks like it's the right atrium. Would we include this? It's very thin myocardium, it's probably just about 50%, so you probably get different opinions from different people. I would be tempted to just have a look at the one slice further down. Now you've got clearly myocardium all the way around, still a bit of outflow tract, so I would be inclined to say don't include this bit. You clearly see the mitral valve here. But I guess if you were to include it, as long as people are consistent, I don't mind too much. But this is a tricky one. I think I wouldn't include this, even though you could argue maybe you've got more than 50% myocardium around here, but it's extremely thin, a lot of partial volume, so I wouldn't include it. One further down, definitely LV I would include with this one, crescent shape. RV, now this looks like you've got trabeculations in the RV, so I think this is part of the RV, and then you get the pulmonary valve here, so I think this is all part of the RV. So we just click through, it actually gets smaller initially, so it is the RV, and I'm sure we'll now move into the right atrium further in. So yes, here, oops, here I think I would include from there, go all the way down. So, oops, go all the way down. That bit I would include, and then here, again you can see the pulmonary valve. So this bit here was the pulmonary valve, so this must be above the pulmonary valve. So I would include that, so that it becomes easier, but really it was about the basal slice, wasn't it? So that's above pulmonary valve, that's the pulmonary valve, so this is part of the RVOT. So RV, that's right atrium, and that we do include, again, pulmonary valve above the outflow tract. Now, let's look at another case. So in systole, if you identify your systole based on the LV smallest cavity, let's say here, that's all RV, we go up, that's all RV. Now you get this sort of clove-like looking part, so the RV, the pulmonary valve is going to come into plane, but this I think I would include at least up to here. One further up you can see change. That looks like it's the pulmonary valve, so I wouldn't include this. And this very likely is the right atrium. Although having said that, it was becoming smaller in systole, so actually I think this is right ventricle and I would include it. And then one further up, clearly shape change, that's right atrium, and that's above the pulmonary valve, so not included anymore. For LV, clearly that's not included. One further down, there's myocardium all around to here, so I would include this as my basal systolic slice for the LV, and you can see you have basically one slice longitudinal contraction. over 1 centimeter. Just try and find one other case to look at it, because I think the basal selection is really quite important. Let's have a look whether we've got the short axis there somewhere. Just drag this on here. I think it might just be loading the short axis cine now. It's Sunday, so it's loading rather slowly. It's probably taking its time because of the weekend. Okay, just bear with me. Okay, it did load all of them. So this is the, again, you can click on here and you can see that this is the short axis cine. Looks like a hypertrophic cardiomyopathy case. If I drag this onto the short 3D, do right mouse click, say window, windowing, min-max, and we really just start looking at it again from the decision to be included. This is a round structure, almost certainly above the pulmonary valve. This looks like this clove-like, probably just about aortic valve plane. This has to be the left atrium. It's very thin-walled. This has to be the right atrium, very thin-walled interatrial septum. One slice further down, you start getting a little bit of muscle in there, but that still looks very much like the left atrium aortic valve, so that I wouldn't include for the LV. The RV, sometimes you have bits that you can include already at that level. So here, this looks like we're very close to the pulmonary valve here. This may be part of the RVOT, but given that it's so small, I probably would ignore that and say, nope, there's no RV yet. Whether this is right atrium or right ventricle, I guess if we're not sure, I'm sure it's right atrium, but let's just go into systole. And I think, whilst it is my own rule of that it does get smaller, so I think this sits right on the cusp of the right ventricle and the right atrium. But I'd be tempted to call this more right atrium. I think this has got the look of the right atrium. So let's go one further down. So that's right atrium. I think that's still more right atrium than right ventricle, even though I think there's some right ventricle in there. This has got clearly the shape of the right ventricle. So here, yeah, it comes in, no doubt about that. Further down now, we're getting to the right atrium. So now here, this is right atrium again, and pulmonary valve. But if we go back, here clearly I would include all of this as part of the right ventricle. And this is clearly all left ventricle. Let's go one slice further up again. Again, that's not left ventricle, basal slice, and I think this also we shouldn't include. So this would be the first slice for both RV and LV. If we go to systole, let's find the smallest cavity. Let's say, oops. Let's say this is the smallest cavity, phase 11. And let's just go up and decide. This one here looks like the right atrium above the pulmonary valve, so there's no RV. And LV, I guess it's less than 50%, less than 180 degrees. So again, I wouldn't include this. But some might argue it's just 180 degree. So I think you just have to sort of be consistent in the way you do it. I wouldn't include this, I think. One slice further down, certainly that's LV. Certainly that's RV, so I would include those. And then you go down, And then it becomes difficult to draw because of the hypertrophy. And that's how I would choose the basal slices. Now one more, and then I think you get the idea, but you also get the idea that actually analyzing the RV is not that easy, and you need to do loads of them, and compare to your LV stroke volumes and compare that to the RV stroke volumes to get confident that you're picking your basal slices correctly. Let's just load this study. And the other important thing is, do save your contours when you've drawn them with workspace. Save my workspace in DICOM, so that we can basically double check your contours and then rather adjust a little bit rather than draw all the contours again. So this is probably the cineum. Yep. So I take this, drag it into short 3D, do my windowing min-max, and we're in the first slice, first phase. So you can see the right coronary artery coming out of the aortic root, so that's the aorta. This is the pulmonary artery, and I suspect it's just above the valve because it's nice and round. This is probably just a bit of the valve. So this, I would think, is part of the RVOT, so I would include this in my RV volumes. Now what I wouldn't include is this bit, because that looks like it's the right atrium. Very thin-walled, that's the left atrium. And if I just go through into systole, I can see immediately that it changes into the shape of the right atrium. So left ventricle we wanted to look at as well. That looks like it's the left atrium, so I wouldn't include it. One slice further down, myocardium, myocardium, myocardium more than 50, maybe 270 degrees. I would include that as my basal slice, but because it's not entirely round myocardium, I would choose this contour. Okay, so the RV more difficult again. This looks again like it's pulmonary valve, but we have already decided that there was some RV visible, so we need to have some more RV visible. Question is this all RV? And I suspect it is. Given that we see so much LV mass, this must be the RV. But let's check by going through the phases. It gets smaller and then larger. So I think this is the RV. And I would probably draw my contour here like this, below the valve, down here, and up. And then one further down, again that looks like it's the valve, down here, and up. And one, then that's the entire RV. Now let's decide in systole. So we've looked at the diastolic one, so here this you would include as LV and this is RV. Now let's just go into what is systole. It was phase, that's the smallest cavity, phase 8. So if I now go up, that looks like it's probably our basal left ventricular slice. You've got about 280 to 190 degrees of myocardium, LV, so you would include all of this. That looks round and looks like it's above the pulmonary valve, so I wouldn't include this bit. This, possibly, let's just go one slice further up to look at the change. So I think here we are really looking at, could argue again, should this be included as a basal slice? You've got some myocardium, about 50, just over 50. Again, you get different opinions from different cardiologists probably. I think I would not include it, given my argumentation in the diastole. But this is a tricky one, you could do it either way. Here, I think this is clearly above the pulmonary valve. And this, you probably do want to include. So let's just see how that shape changes intersystole. Very tricky. You can see it's not easy, but I would probably include that as the RV. Okay, I think that gives you an idea, but practice, practice, practice is really the most important thing. And as you can see, I've not chosen to show you any cases that are very easy. They were just random ones that are anonymized on my computer, and therefore really shows you how difficult it can be. But you need to basically just do it, and then you get much, much more confident. Okay, I think that's it. Thank you very much for listening, and I hope you find these cmr42 tutorials helpful. Thank you. Bye.